Hi, I'm Ken with TinyCircuits, and I'm joined here with Tony Betty, one of our engineers. And today we're talking about a brand new TinyShield. This is a barometric pressure TinyShield. It's based around the BMP 280 from Bosch, and it can also be used to measure altitude. And so as a first test, Tony put together this little project, so tell us about it.
Yep. So I created a data logger using a processor, lithium battery, SD card shield, and the pressure sensor. You got a nice little stack here. And it fits nicely inside of the rocket. We can just pull off the nose cone. There's a little hollowed out spot. And then it just fits nicely in there. Like so.
Okay.
And you're ready to go.
And what does it do with the data? So it logs to an SD card. How does it do that?
Yeah, so the data is logged to the SD card, and it can go up to 99 trials. It'll be saved as a CSV file, so you can open it up directly in Excel.
Okay. And how often does it log the data?
Every 30 milliseconds.
Okay. And this rocket looks like it's been beaten up a little bit, and there's a reason, right? Because we've actually launched these already, so this is kind of after the fact.
Yeah.
The issue with this one was we had some parachute deploying issues.
Yes, I didn't put enough wadding, and then I put too much, and it melted the parachute. So we didn't have a full deployment each time.
Yeah, but we had another rocket. So this is about a 2-inch diameter rocket. We have another one that's 1-inch diameter. And so now we're going to jump over and actually review the rocket data from the field.
This is my first rocket launch.
And we used a C engine for this. So it takes off. If you notice right there's a little bump. We're guessing that's like a pressure change, right?
Yeah, the second charge to deploy the parachute.
Yeah, and then if you see coming down, it looks really nasty. That's because the parachute didn't actually deploy here. So boom, get a nice big crash landing. But the nice thing is the circuitry survived, so we got the data.
Wait, that dip. Okay, so that's actually the rocket's not actually going down. It's actually just a change in pressure, and the change in pressure is caused.
That's what we're guessing.
Yeah, because you see the same little blip in the second launch here.
Yeah, so the second launch does a little bit better. We get a little bit higher, but then again we still had an issue with the parachute deploying.
Yeah, the first launch had too much wadding. This one had not enough, so the parachute kind of came out, but it was a little melted.
And here we are retrieving the rocket. You can see the parachute obviously didn't come out, but still is in good enough shape. The circuitry was fine. We can reuse the rocket another day.
The parachute looks melted.
It did melt a little bit, but we got all the circuitry fine. Now this third test, this actually uses a longer, skinnier rocket.
Yep.
And this one you can see actually goes up much higher, and also coming down. We didn't have a parachute, we were using streamers on this. So it greatly slowed it down coming down, so that's why it's a very nice descent.
Well, what are streamers?
Oh, they're just like two little
Streamers.
Streamers.
Cool. Okay.
Well, you'll see them.
Like bicycle handle streamers?
No, Andy used construction streamers.
Construction streamers.
Yeah.
Okay.
But definitely the controlled descent is nice. So the rocket was in beautiful shape, and here it comes back into view. So there's your streamers that you see.
Oh, sweet.
Lands. Tony almost got hit with it.
I was trying to catch it.
But yeah, this one has the circuits in the nose cone, so we pull it out, and everything is nice and pretty on this one.
Nice.
Now the final launch, we decided to kind of go crazy. So we put an E engine in it. This is actually supposed to be a multi-stage launch, which didn't quite work out that well. But you can see the E engine takes up really high, so we actually reach over 2,000 feet. So about 1,250 feet total elevation.
Yeah, we actually lost sight of it, and we found the bottom part holding the first stage first before the actual rest of the rocket.
Yeah, we did find the rocket about 20 minutes later. You can see it just came down, didn't deploy the parachute or anything because it didn't actually light the second stage. Pretty cool. It kind of hit the nose, and the circuitry actually popped out, broke the plastic of the nose cone. So you see the TinyDuino stack poking out the side. The SD card fell out, but it was logging data up to the very end. That's why we were able to get that nice curve.
It would be nice if we had an accelerometer on there. Oh, it would have just capped out anyways, right?
Yeah, that'll be for the next rocket launch.
For the next launch.
So here's the code for our data logger. We use the BMP 280 from Bosch. Right here we set up a serial port for debugging. We check to see if the SD card is present. Here in this while loop, we reference the data file right here. And it checks to make sure that if a file exists, it'll increment the file number up by 1, and it'll keep going until it finds one that does not exist, and it will then create that file. So you can have up to 99 launches on one SD card. Here we sort of set up each file just like a little header. It says the rocket launch number, sets up the altitude, time. And then down here is our main loop. We start the BMP measurements. We can also get temperature. We check to get the altitude, which is in meters. And then we write that to the SD card. We multiply that by 3.28 to get it into feet. We log the seconds, and then it closes. So here you can see the headers that we set up, and then the altitude is logged in feet and the time is logged in milliseconds. And you can see we have about 200 data points down here, logging every about 30 milliseconds.